Welcome to Jacob Bourgeois' presentation on mathematical origami. The art of origami was first invented in China in the 2nd century and was brought to Japan in the 6th century. It involves folding square pieces of paper with no adhesive. Origami as a system of mathematics was developed in 1989 by Huzita-Justin, laying out the 7 axioms of origami. These 7 axioms describe all different types of folds one can accomplish. In this presentation, I will review the 7 axioms of origami, show how to use origami to solve cubic equations, and show how to fold a paper balloon. The first axiom says, given 2 points, P1 and P2, there exists a fold that passes through them. So in the plane we have point 1 and point 2, and there's a fold that will pass through both of those points like so. Alright, moving on to the second axiom. It says, given 2 points, P1 and P2, there exists a fold that places P1 onto P2. So this will put P1 and P2 on top of each other. And here's the fold here, exemplified. And you see how P1 will go onto P2 in the plane. So those are the first 2 axioms. Moving on to the third. Given 2 lines, L1 and L2, there exists a fold that places L1 onto L2. So it's kind of like the second axiom, but with full lines now, and it's making the lines go directly on top of each other. If we do this fold here, the 2 lines will become one and the same, and be vertical there. Alright. Fourth axiom. Given point 1 and line 1, there exists a fold perpendicular to line 1 that passes through point 1. So we have a point and a line, and we want a fold that's perpendicular to the line that passes through point 1 like so. And that fold will look like this in origami. Alright, now we have axiom 5, and axiom 5 makes it to where origami is now as strong as construction, Euclid, compass, and straight edge construction. And this will make our origami method able to solve everything construction can. So given point 1, point 2, and line 1, there exists a fold that places point 1 onto line 1 and passes through point 2. So we have 2 points and a line, and I'm saying I can put P1 onto the line with a fold that passes through P2, like so. If I fold this, P1 will go onto line 1, and the fold's around about P2. It's on the line. Alright, that's the 5th axiom. And the 6th one. Now with the 6th and the 7th, origami will surpass construction. You'll be able to do more problems using origami as you would regularly be able to do with just compass and straight edge construction. Given P1, P2, line 1, and line 2, there exists a fold that places P1 onto line 1 and P2 onto line 2. So we have P1 and line 1 and P2 and line 2. I'm saying there exists one fold that will put P1 on this line and P2 on this line. And that fold in this example happens to be this, where over here you see P1 goes onto the line, and P2 over here will go onto the line. So that is the line in axiom 6. And our last axiom, axiom 7, says, given point 1, line 1, and line 2, there exists a fold that places point 1 onto line 1 and is perpendicular to line 2. We got a line 1 here, line 2, and a point. I want to make a fold that's perpendicular to line 2 that places point 1 onto line 1, like so. You see how it goes onto the line, point goes onto the line, and the fold is perpendicular to line 2. And those are the 7 axioms of origami. Now we will be discussing how to solve a cubic equation using our origami techniques. We will be looking at cubic equations of the form x cubed plus ax squared plus bx plus c equals 0. We're going to define 2 points and 2 lines on our coordinate system of the y-axis and x-axis. Point 1 will be at A1, so we'll go over A and go up 1. CB will be point 2, go over C and down B. Line 1 is x plus 1 equals 0, shown here, line 1. and line 2 is x plus c equals 0. Right here is line 2. And we notice that this is a 1 here. There's a 1 difference between the line and the x-axis and the x-axis and point 1. And there's also a c difference between point 2 and the y-axis and the y-axis and line 2. There's a difference of c here as well as here. Now, to solve this equation using origami, we will use our axiom 6. Now, axiom 6 says, given 2 points and 2 lines, I can put point 1 on line 1 and point 2 on line 2. And that's what we're going to do over here. Point 1 we want to go on line 1, and point 2 we want to go on line 2. So if I do this fold, point 2 is going to go over here to line 2, like so, on line 2. And point 1 is going to come over here to line 1, like that. Point 1 going on line 1, like that. So this is that fold that we were looking for, and the slope of this fold will be the answer to this cubic equation. Another application of origami is making 3D figures. I learned how to make this type of balloon in elementary school from friends, and this knowledge has stayed with me all this time. In the movie James and the Giant Peach, James makes a large balloon with this type of method using lightweight paper and turns it into a hot air balloon with a candle and string. Now I will teach you how to make your very own private hot air balloon. Now the first step is to fold the square piece of paper in half 4 times. You want to fold it vertically in half, horizontally, and diagonally in both diagonal fashions, like that. And then once you have it like with those 4 creases, we will bend it up into a bowl-like structure like so, where you're making a triangle, and it should look just like this. It's kind of hard to get it to go into this shape, but after you have it just like that, you will turn the triangle into a square by flipping the flaps up at right angles to the bottom here, where this goes up at a right angle. So now we have a square, and we're going to fold the sides of the square inwards to the line in the middle on both sides, so on that side and on this side. And now these bottom parts, we're going to fold them up and tuck them into these openings that were created when we folded the sides in. So I'm going to put that one inside there, this one inside here, flip it over and do the same on the other side. Flap goes inside of the fold inside here. And just to get all the creases nice and neat, we'll fold it out, press it down a little bit, and we have our balloon with the top is the opening here. You have a balloon. See? Math is fun for hours, fun for the kids, fun for mathematical theory. I hope you've enjoyed this presentation, and have a good day.